Please make sure before watching this video that you did in fact complete that sheet with a table of values for cosecant and secant. I will be referencing it throughout this video, so it would be helpful for you if you want to have that out with you while watching and taking notes on this. When we graph cosecant and secant, we're going to use the graphs of sine and cosine to help us. So the better you are at graphing sine and cosine, the easier this is going to be to understand. So first thing I want to talk about is, when is cosecant undefined? Well, if I look at my table that I filled in, I notice it's undefined at negative pi, at 0, at pi, at 2 pi, at 3 pi. And had my table continued to go on in either direction, I would have continued to see that it ends up being undefined at multiples of pi. So I can say it's undefined whenever we have pi times any integer. So at pi n, pi times 0, pi times 1, times 2, pi times 3, pi times negative 1. Or we can also say, and this is going to be more helpful for us when graphing, it is undefined when sine of x equals 0, which should make sense since cosecant is 1 over sine. So when we look at the graph, remember that we're going to, if we have an undefined piece or an undefined value, we're going to have a vertical asymptote there. And if you remember, a vertical asymptote is going to be an imaginary line that a function can get extremely close to but never touch or never cross. So I'm going to go ahead and everywhere it was undefined, I'm going to put in a vertical asymptote. So we started at negative pi in our table. And it was at negative pi over 2, negative 1, undefined at 0. So notice I'm using a dashed line to show that it is an imaginary line, and therefore, because I'm making it dashed. So just plotting all the points that you have already found from your table, and the final undefined piece. And so now again, based on the definition of a vertical asymptote, I notice that I cannot cross these asymptotes or these lines. So my function's going to have to stay in between here and go through my point. My function's going to have to stay in between here. So it seems to me I'm going to have multiple pieces of my function. So I'm going to go ahead and I'm going to find one other value to help me graph it, and I'm going to go ahead and say, what is cosecant of pi over 4? And I should have put this on your table, but I didn't. It's approximately 1.414. And all I'm doing to find that is I'm pulling that value 1 over the sine value of square root of 2 over 2 and approximating in my calculator. So at pi over 4, which is between 0 and pi over 2, it looks like I'm at about 1.414. Well, if I did the same thing for cosecant of 3 pi over 4, what I'm going to find is I get the exact same value. And 3 pi over 4 would be about here. So it looks to me that my function, and I could plot more, is going to look something like this. And what I'm going to find out if I do that and plot some more points and find some more values is that it's going to mimic that in each of these intervals, alternating between going up towards infinity and down towards negative infinity. This is going to be the graph of my cosecant function. Well, look at here. Look at what is lying underneath my cosecant function. Underneath my cosecant function, you're going to see that I have my sine function. So what we're going to do whenever we graph cosecant is we're actually going to first graph the sine function, and then we're going to go ahead and just fill in our cosecant function from there after drawing in our vertical asymptotes wherever our sine function is 0. We're going to do the same thing with secant, except notice that if you look at your sheet, that secant is undefined at pi over 2 plus pi n, or when cosine equals 0. Again, there's going to be a vertical asymptote there. So what I'm going to do is I'm going to do the exact same thing for secant as I just did for cosecant. I'm going to go ahead and I'm going to draw in all my asymptotes, and I'm going to plot all the points that you found on your table. And again, I'm just using that dashed line for my asymptotes. If I again pick a test point, what you're going to notice is that secant looks almost identical to cosecant in the aspect that once again, I'm going to have these U shapes in between each of my vertical asymptotes. And so at first you might think, hey, that's the exact same function. But you're going to notice, just like sine and cosine look very similar, but their starting points are different, it's the same thing that's true between cosecant and secant. Notice that my asymptote shifts, and it's essentially the same function shifted. But underneath the secant one, we have our cosecant function appearing. So notice once again, to draw secant, we're going to start by drawing our cosine function and then sketching our secant function in. So let's go ahead and look at an example of how that's going to work. So I want to graph cosecant of x plus pi over 2. So to do that, I'm actually going to first graph the function sine of x plus pi over 2. So I'm going to find all my important information. So I'll find my amplitude, which is 1. I'll find my period, which is 2 pi over 1, or just 2 pi. My space between points, which is going to be 2 pi over 4, which will just be pi over 2. My phase shift, which will be negative c over b, so negative pi over 2 over 1, which is just negative pi over 2, and my new interval, which is going to go from negative pi over 2 up to 3 pi over 2. And now I'm going to go ahead and graph this. So sine would normally start at 0, 0, so I'm going to shift back pi over 2 and start there. And then I'm going to go a distance of pi over 2, go up to 1, a distance of pi over 2, a distance of pi over 2, similar to what we've been doing in class, and I'll put some back as well. And I probably won't use this entire graph that I've got here. That should probably be enough. That will get me more than one cycle, and I'm going to go ahead and I'm going to draw in my sine curve, and you do not have to draw in your sine curve. And now I'm going to go ahead and switch colors, and I'm going to draw my cosecant curve, since I wasn't really asked to find this curve here. So let's go ahead and use this green. So I'm going to draw my asymptote in wherever my sine curve is 0. And then I'm going to go ahead and put in my cosecant curve, and as in the form of those U's essentially that are falling in between my asymptotes. And like the sine or cosine curve, I can continue this and have this go on for as long as I wanted. Let's go ahead and look at now with the secant, and we're going to look at how we can use cosine to help us out with that. And I will also show you on this one how I can graph it without actually drawing the cosine curve in. Alright, so once again, first thing I'm going to do is I'm going to go ahead and I'm going to find cosine of, and let's put the 2 out front, so let me erase that. I'm going to go ahead and first graph 2 times cosine of x over 4. So remember that x over 4 is the same thing as 1/4 times x. And I'm going to go ahead and first find my amplitude. So my amplitude is 2. I will find my period by taking 2 pi over b. b is 1/4, so I'll have 2 pi divided by 1/4, which is going to be the same thing as 2 pi times 4, or 8 pi. I will find my space between points by dividing 8 pi by 4. 8 pi divided by 4 is going to be 2 pi, so notice this is being horizontally stretched quite a bit. And my new interval, well, I'd actually find my phase shift next, but notice my phase shift, since I don't have a c, my phase shift will just be 0 for this. So my interval is going to go from 0 up to 8 pi. And you can see on my graph, I'm not going to be able to show that whole thing because I don't go all the way up to 8 pi. I think I have it up to 4 pi if I move this over a little bit. And I apologize because I know you can't see my writing very well. But I'm going to go ahead and graph this cosine function. So first thing I'm going to do is, since there wasn't a, there is no phase shift, is I'm going to start at 0, but instead of going up to 1, because of my amplitude, I'll go up to 2. Then I'm going to go a distance of 2 pi. I'm going to put my next point. I'm going to go a distance of 2 pi and drop back down, and I'll drop down again to -2 because of my amplitude. And I'm going to do the same in the other direction. 2 pi and go down to 0, and a distance of 2 pi and drop down to -2. So obviously I'm not going to get 2 complete cycles in here. I'm going to, it looks like, just get 1. But, so what I could do from here is I could either draw in my cosine curve, like I did in the last one, or if I don't want to draw my curve in, and it does not matter to me which you prefer, I could simply just use the 0 as guidance to turn in my asymptotes, and then use these points as the maximum and minimums of the parabolas that I'm putting inside of each of these asymptotes. And that is all that will fit on my graph. So very, very large graph. But that's going to be how we graph sine and cosecant and secant. So once again, graphing the sine and cosine first, using all the information that we've been learning in class to help us with that graph.